All right, in this video, we're going to work through this example of solving a triangle. So we have a right triangle that we want to solve. And in this case, they have given us the lengths of all three sides. And so what we need to do is to find the measures of the angles. Okay, and so what you want to do is just start off with one of the angles. I'm going to start off with A, right? And in here, we can see we have, we're going to use a little triangle trig to do that. And so we have all of the sides related to of the triangle labeled, or we know the lengths of all of those. So we can essentially use just about any trig function we want: cosine, sine, tangent. It doesn't matter. Okay, on this particular problem. So I'm just going to go with cosine. And the cosine, right, of an angle would be the measure of the adjacent side divided by the measure of the hypotenuse. Okay. The hypotenuse is the easiest one to find because it is the side opposite the right angle. So 60 square root 65. So that would go on the bottom. And so next up is the adjacent side, right? These are the two legs, this one here and the one of length 4. And remember, the adjacent leg is the leg that is actually forms part of the angle. So that's this leg right here is the adjacent one for the angle A. All right, and so that goes on top. All right, and then now we just solve that equation, right? We want to find the measure of angle A. So we take the inverse cosine of both sides. So we take the inverse cosine of A, and that has to be equal to the inverse cosine of 7 divided by square root 65. Now you may be wondering, why didn't you rationalize this? And it's because we're going to have to use the calculator anyway to do this. So. All right, over on the left-hand side, we use the fact that the inverse cosine function and the cosine function are inverses of each other if, right, we're on the interval from 0 to pi, and A, right, is obviously got to be an angle that's between 0 and 90 if it's part of this triangle. So that's certainly valid. So over here on the left-hand side, we'll just get A, and then we'll go to the calculator. This is not one of the values on the unit circle, right? And so in this case, let's see, I did not specify whether or not they wanted it in radians or degrees. So let me just quickly take a look at that. All right, it says in degrees, and so that needs to be specified here. I did not write that down. So we want degrees here. Well, this is from one of the Newton problems, and the way that I know that it's degrees is they have little degree symbols in the answer boxes. They're really, really tiny, but they have them there. So you're just going to have to kind of look on these problems. Okay, so we want to do make sure that we're in degree mode, all right, which we are. And then what we want to do is inverse cosine of 7 divided by the square root of, and that is right here on this calculator, 65, and then right arrow like so. All right, and so we get 29 .74 degrees. That says round final answers to 1 decimal place, right? So that will be 29.7 degrees on that one. All right, and so we have angle A. The only one left to figure out is angle B. You could go through this process again, but there's really no reason to, right? And so because we know that all of these angles add up to 180, and this is a 90-degree angle, that the measure of angle B and the measure of angle A have to add up to 90 degrees. So we can find the measure of angle B by subtracting this from 90, right? So B is 90 degrees minus this 29.7 degrees. Okay. And so just be a little bit careful when you are making the calculation. Don't, especially if you're using a rounded value in your in this calculation, because it will throw these answers off and then Newton won't accept them. So you're better off taking a few extra decimal places, like 90 minus 29.7448. Just a few extras, right? And so you get 60.3, right, to one decimal place on that one. Okay, so again, don't round off too much in intermediate calculations on this, just to be on the safe side. It comes out the same here, but there are other places where, you know, it might throw your answer off enough to where Newton gives you some grief over that. Okay, all right, and so that is it on this example.